We can go ahead and start with the 45 who have joined. So I see Diana is already on the call. Thank you so much. Welcome to another job mentorship session. My name is Faith, and today we'll be talking about securing microservices, which is something very vital for developers and anyone really dealing with applications. So with us is Diana Ndinda Nyamai, who is currently an integration engineer at Safaricom. So she has specialized in building secure and scalable microservices and is very equipped to take us through this topic. So without saying any further things, I'll go ahead and just welcome Diana to the session. Karibu sana to Cyber Shujaa Job Mentorship session. Hi, Diana. Hi.
Hi, can you hear me?
Yes, we can.
Okay, thank you. Hi, everyone. Thank you so much for joining. My name is Diana Nyamai, and I'm an integration engineer at Safaricom. And today I'll be walking you through a topic that's close to what I do daily, that is building secure microservices. I'll try to break it down in a simple and practical way and give you a glimpse of what it's like in the industry. So, at Safaricom, I work as an integration engineer. I design and maintain reusable microservices that enable systems to talk to each other, like CRM, billing system, and all that. And I focus on building secure and scalable services that handle real customer data. So before we dive into microservices, I'd like us to look at what came before. That is the monolithic architecture. And in a monolith, the entire application was one big unit. So whether it's logging in or processing payments, all that logic was in the same code base and deployed as a single unit. So let's say you have a shop application, the user login, the payments, the product listing, and even the order history. You had to have it in one place, and you also had to use one language. And in the case where you want to update just the payment logic, you'd still have to redeploy the entire application. And this made it so hard to scale and slow to update and really risky, because with just one small bug, it could affect everything. And now that's where microservices came in. You can think of microservices like small specialized apps that each do one job really well. For example, one service might just handle SMS sending, then the other handles payments, then they all communicate with each other through APIs. And now in this architecture, it just makes systems easier to manage and to scale. So why would you use microservices? So microservices allow companies like Safaricom to move faster. So if one service has a bug, it doesn't bring down the whole system, and the teams can can deploy features without stepping on each other's toes, and you can test and roll back services independently without affecting others. For example, if you want to launch a feature, you can go live without waiting for CRM teams, and each team can focus on a specific service like payments or subscriptions. And this means there is now more ownership to the service. You get to own a particular service. So if anything goes wrong, you can correct it and now deploy the service again. There's accountability and also faster delivery. Then teams can also pick right tool for the job. So you don't have to use one technology. One service can use Java and another can use Go as long as they communicate over the APIs. And you can scale only the services that need resources. For example, during Black Friday, you can scale the payment and checkout services, but you wouldn't need to uh, scale the profile service. And you can also now apply security at the service level, and sensitive services like payment or user data can have higher security controls than the non-sensitive ones. So security in microservices. With microservices coming into the picture, the challenge is now you have small services communicating over the network, and each service becomes a door. And now every door needs to be locked. And without proper security, an attacker can easily exploit a weak point and gain access to sensitive data. For example, let's say you have a payment service, a customer service, and maybe a catalog service. So if the product catalog is misconfigured and doesn't authenticate requests, the attacker can easily use it as an entry point to try to move into the payment service, especially if the internal APIs are open and unprotected. And unlike in a monolithic application where communication happens internally within the same code base, microservices communicate over APIs, usually HTTP, across networks, which now introduces more surfaces for attack. So how do you get to now secure the microservices? So one is authentication. This is about identity, and you need to be sure that the person or the system that is trying to access your service is who they say they are. And in simple terms, if someone knocks at your service door, you need to ask, tuuliza wewe ni nani, umekuja kufanya nini hapa? So in microservices, we use methods like basic authentication, JWT, which is JSON Web Tokens, OAuth, and API keys to verify identity. Next is to secure communication. Now, imagine sending a letter without an envelope. Along the way, anyone can read it, and that's what an encrypted API is like. And we use HTTPS to encrypt data in transit between services and clients. Even inside a trusted network, you don't leave data unprotected. The other one is using API gateways. You can think of an API gateway like a security guard. And its work is to check authentication, to rate limit traffic, it can block suspicious requests, and all that. For this, you can utilize tools like RPG, which is by Google, AWS API gateways to help you do this. Then the other one is input validation. This is one of the oldest rules in programming, and you should never trust what a user sends to your service. You should always validate and sanitize your input. And this protects your microservice against SQL injection and XSS attacks. And for the sake of those who do not know what they are, because I know there are people who have joined who are not techies, an SQL injection is a type of injection where a cyber attack, where an attacker a black hacker. This is yule hacker mbaya. Those who try to steal data, cause damage, and disrupt services. They inject an SQL code into a query in order to access or to alter your database. It's like someone whispering a secret password to your lock, and then your system just opens up everything because it doesn't know better. And then the XSS, which stands for cross-site scripting, is also a vulnerability where attackers inject malicious scripts into web pages that are viewed by other users. And for this, it's like leaving a sticky note on your fridge, and then when you read it, your fridge just opens the door and gives away snacks to strangers. So why should you care? I think even if you're not a techie, if you use online platforms, which we all do, these attackers can affect your personal data, your banking information, or even your identity. And that's why developers and companies work so hard to secure your systems so that they can protect users like you. So the other way is logging and monitoring. I'd say security doesn't end once you build something. You have to keep an eye on it. And you can utilize tools like login tools like ELK or Grafana Loki, which are free too. And you can set alerts when something strange happens, or if you can monitor for any unauthorized access or unusual patterns in your services. The other one is rate limiting. I want you to think about what would happen if someone hit your API like 10,000 times per second. Your service will most likely crash, or even worse, get compromised. So you can implement rate limiting to protect your service, and you can use API gateways to handle this too. Also, tools like Bucket4J and Spring Cloud Rate Limiter can help you in Java-based microservices. So next, what happens in the industry? Before anything goes live at Safaricom, it is tested thoroughly for security, and the APIs must meet certain standards. And this is not just a formality, because with weak security, it means there's legal risk. Also, you lose customer trust or even outages. And yeah, now we've come to the demo part of the session. I've built a simple Spring Boot service to help demonstrate the concepts that we've discussed. And this particular service has been implemented using basic authentication, just to give you a feel of how we can secure endpoints. And I'll walk you through the implementation step by step, and we'll test it together so you can see it in action. And don't worry if anything looks unfamiliar, I'll explain as we go. And my goal for you is for you to leave this session with a clear understanding of not just how things are built, but why they are built that way. So here we have security configuration class. This class sets up basic security for Spring Boot application using Spring Security. And you can see at line number 12, we have the annotation and configuration. So this tells Spring Boot that this class contains security-related configurations. And these are basically instructions for how to secure the service. Then from line number 14 to 23, we have the in-memory user details bin, which now which sets up the test user who can access secure endpoints. In this case, I've set the username as Diana and password is password123. And you can see there's that noob under those curly braces that tells the Spring not to encode the password and just use it as plain text. And please don't use this at work. This is only used for demos. You should always validate tokens and avoid storing password in plain text.
Diana?
Sorry?
Sorry, let me just pause you there for a bit. I see a couple of hands going up. Just in case, before you move on, maybe there is a question. Is that fine?
Sure.
Okay, so I've seen a hand. Evans, your hand is up.
Okay, thank you. But I wasn't able to see the screen, but now I can see it. That's why.
Okay.
Yeah.
Okay, thank you. Anyone else who cannot see the screen?
Same here. I can't see. It's on the demo screen.
Give it a bit of time because it also just switched for me.
Okay, thanks.
Also for me,
let me know if you see the screen.
I'll also beg you enlarge the screen a bit.
Oh, sorry.
Tevin, same issue?
I think, is that the maximum you can maybe do?
Just a minute.
Okay.
Is that better or should I increase the font?
I think the font, change the font a bit.
Is that better?
Yeah. Very nice, very nice, very nice.
Okay, great.
Thank you.
Okay.
Should I?
Continue.
Okay. All right.
Yeah. Continue explaining nicely now.
All right.
Okay.
Where was I? Yeah, the roles.
Okay.
Yeah. So we set the role as user, and this is important because we can get to restrict or allow access to certain endpoints. And then now we get to return the in-memory details manager. This means that we are going to store the user in memory and we won't need database. This is also good for small test hubs. So next from line number 24 to 33, we have the security filter chain. What that does, it configures how the app should handle HTTP security. And the requests with the /public means that they are open to everyone, so no authentication is needed. So that's why you have that .permit all. And then any other request will need authentication. You'll have to provide valid credentials for you to access any other route that doesn't have, that isn't public/public. Next, we go to the controller. The controller is a Spring Boot REST controller that exposes two simple endpoints. That's the public and the private. And it's just part of demo application to illustrate the difference between a public and a secured authenticated route. And when we hit the first route, we expect to see, hi, this is a public endpoint, no authentication required text. And then if we try to hit the second route without authentication, we should not expect to get this response. We should see this response after our valid credentials. So I'm going to use Postman to test the endpoints. Let me know when you see Postman.
Diana,
Yes.
there's a hand from Francis. Is that a question?
Yeah. Can you hear me?
Go ahead. Yeah.
I was wondering if you could use HTTP sessions as a valid mechanism for the authentication.
Sorry?
I was wondering if you could use HTTP sessions as a valid mechanism for authentication.
HTTP session.
Yeah. So like storing the user's just the user as an object in a session, and then being able to access and determine like the type of role the user has so that they can have access to the microservice.
Well, I had purposed to make it as simple as possible to make sure that everyone can, even those who are non-tech, can get to understand it without adding any more complex authentication.
And I agree with you actually. You should just continue that way, maybe. It's quite efficient for people because we are looking to reach everyone so that everybody can understand. Isn't it, class?
Yeah, it is. I think she
Yes.
should continue and probably save a session for questions afterwards. Because if
Yeah.
we continue like this, nothing will be accomplished.
I agree, bro. I agree. So I think she can proceed. Sorry, my boy. I think we'll just proceed this way for everyone's conveniences because you need to look out for others also. That's what real human beings are.
No, it's fine. I was just curious.
Okay,
Aye.
Diana, go ahead. Thank you.
Okay, so let's start by testing the public route. As you can see, we have received the text this: hi, this is a public endpoint. No authentication is required. Now let's try accessing the private one. You'll now notice we have a 4.1 over here, unauthorized response, which means the API is blocking access because we haven't provided valid credentials. And so let's go ahead and provide the username and password. So the username is Diana and password is 123. If we hit the response again, we now receive a proper response. Hi, this is a secured endpoint and you are authenticated. And that wraps up the demo. And now before we go to the Q&A, I'd like to say best engineers don't just write code that works. They also think about what could go wrong, and you should always ask, can someone misuse this endpoint, or what if the authentication fails? So I think with that mindset, it will help you build more secure and trusted systems. Again, don't wait for a job to get hands-on. You can start small, you build a service and add basic authentication, then try to break it. You can also learn from communities on X or GitHub. And with that, you'll build a muscle memory that sets you apart. And now I'd like to hear your questions, ideas, or even your experiences so far with APIs and security.
Thank you. Thank you so much. That was amazing. Thank you so much for just explaining this in a way that is very very relatable and understandable. So let's open up for Q&A. Emmanuel, go ahead.
Yeah, I wanted to ask, the project that you are using for your demo, is it a specific project that was doing something, or were you using a template of sorts?
Well, it's not a template. It's just when you start creating a Spring Boot service, there's an initializer. So you just go and create it and you start building your service from there. I did that for demo purpose, so it wasn't an existing service.
All right, thank you.
Charles?
Hello. Thank you for the opportunity. Now, Diana, I want to confirm something here. I'm largely a PHP developer, and I was wondering. I know most of my projects are monolith, but now the way you explained how microservices work, I'm beginning to think as if I have microservices in them. So, for example, a project that has a cell processing script, let's say that, and after the user decides to process that cell, a cell ID is passed to that script, maybe through a GET request. And that script collects everything about the cell from the database, processes it, and stores it again, and then returns a response to the user. Does that qualify to be a microservice? Thank you.
So is the code in part of the main part of your project?
Yeah,
or
like
is it
this,
separate?
they are hosted together.
Mm-hmm.
They are in the same folder structure, or yeah, they are the same. I know they are monolith, but I tend to believe that they are operating as if they are microservices. So I want to confirm, where are the boundaries? How do we decide which is which?
Well, for microservices, you don't have them in one repository. You build them in mono repos. So if it's a service for payment, or you said it's for
Cell processing.
cell processes, you will create a repo for cell processes and then now integrate it with your main project or application. So
Okay.
I don't think that qualifies to be a microservice.
Okay, and for the microservices, do they share databases, or each microservice has its own database?
No, they can share databases.
Okay,
So,
thank you.
for example, if you are creating a user, you can access the same database as someone creating a service on retrieving the users. So you can have a microservice to create a user and have another microservice to get the users.
Okay, thank you.
Okay.
Naomi?
Good evening.
Good evening.
I have a question.
Mm-hmm.
Just in general, like as an engineer doing code, have you ever reached a place at how, like, even you can e-code, you can do it, yes, but umefika mwisho, like it's not going to work, not exactly it's not going to work, never, you haven't gotten the solution, I think that is like my first question. Then the second one is, okay, ujapata solution. So you go to your boss, you explain the journey, what you've done, and then your boss tells you, it's not like exactly you umalize like 100%. He just wants to see it work like 40%. And my question is, what does that mean? But sijui kama you can understand my question.
Yeah, I think I do understand your question. So, yeah, of course, there are so many instances where you don't have the solution to the problem you have, and it's okay to ask for help. You don't have to, die with the problem that you have. It's important to know to also collaborate with people in the community or your colleagues if you're in the workspace. So if I go to my manager and ask for a solution for help, and he expects me to complete it, I'll definitely go to my teammates or colleagues, and akuwezi kosa mtu hana solution. You always find solution, and also there's internet where you can, and now AI where you can always find a workaround through a problem. I hope I have answered your question.
Yes, you've answered like part of it, but ukiambiwa like your code should work 40%, or let me just say 50% of it, what does that mean?
Well, it means that your boss knows that you're still working on the full solution, but he just wants to see some progress that proves the approach is working. Well, he doesn't expect a finished product. Maybe a small piece that's showing the API is calling, or at least the application is running or something, or the database returns something. So it's like saying, just give me a proof of concept or a small working demo, or even if it's incomplete or bad code. Yeah. So you're not completely blocked. So your time is being used in good direction.
You have answered my question, and the last question that I have, maybe I've not done my research very well. Do we have free VPN API keys?
Let me see. Well, no, I don't think so. I don't think if there are any VPN API keys.
Okay, thank you.
Thank you, Naomi. Emmanuel, is that another question?
It's another Emmanuel.
Oh, sorry. Go ahead.
If I intended to ask Diana, thank you for the session. I just wanted you to talk about the relationship between APIs and gRPC. How do you integrate the two? I'm asking because of I was doing a project, an API, but using C#, developing forms that could take form records and form fields, something of the sort. And I didn't get to finish it, but in the last, in the description, they were talking about communication between gRPC and the API. So I just wanted you to talk about that so that I could understand, because I didn't get to that part. Thank you.
So for APIs, there are two systems how two systems communicate, and they define what can be done, like get customer info or update a profile. And then gRPC is now a protocol. It's a way to implement the APIs, just like REST. It's more efficient and powerful option, especially in microservices architecture. So, well, in APIs, you can think it as a menu. Then gRPC, you can think like a waiter who delivers the order really fast and efficiently. Yeah. I hope that answered your question.
So you have to do the API first, then now is it like a deployment? Is it like a usage? Is it like it's a container where you now pass it through, pass it to?
No, it's a protocol. Okay, just like I've tried to explain, it's just like REST or GraphQL. So it's a way for you to now communicate with services. So it's it's like a middleware. So it's a protocol that helps you communicate, pass information APIs. Okay. So a protocol, instead of JSON for speed, it allows multiplexing, and it is faster and efficient. And well, the gRPC also has things like streaming and authentication, and ways you can integrate gRPC into your API. You can design the API using protofile instead of a typical open API spec. And you can also implement the server logic. What we using whichever language you want, to either Go or Python, and then you call it from client using the generated classes. So an example, you can build a gRPC service that handles create user and to get user, and then you expose REST API for front-end application, and then now internally your REST controller can call the gRPC service to do the actual logic, so that your API is in REST on the outside, and then now the gRPC is on the inside.
I think I get it now.
Thank you so much, Diana. Martin?
Thank you, Diana, for the section. I think it's very helpful for the developers. My question is, we have the API part and for example, on the web portal. So I had this auditor who was doing a parametric assessment. So he was like requesting that I should hide the endpoints on the network when you open the portal. When you're doing a request, when you open the network, you should hide the endpoints. I don't know, is it, Diana, is that possible? Maybe. Thank you.
Can you ask again? I didn't get it.
What I'm saying,
Mm-hmm.
so for example, you have your backend APIs and you have your web portal, right?
Mm-hmm.
So when so the auditor was arguing when I do a request from the portal, when you inspect and open the network, I should hide the endpoints. The endpoint should not be visible on the network. So
Okay.
Yeah.
I think I've gotten your question.
Sorry?
Yeah, yes, I've gotten your question.
Yeah.
Yeah, well, it's important to, to hide your endpoints, especially on the front end, because it communicates with your backend API. So, so if you expose that endpoint on the front end, and then someone opens the browser, they can be able to see that URL. But if you hide it, they won't be able to see the URL. So, well, you don't have to completely hide it. So if your front end is in the browser and it's making calls to the backend, those requests have to be visible to the browser. And if anything, the browser can see, a user can see too, including the API URL, the request payload, the response method, kila kitu.
So, no way we can hide that from the network.
So instead, you can just make them secure and limited in exposure.
Okay.
So yeah, the goal is not to hide the endpoints, but to give a false sense of security. So instead of just focus on securing the data and actions behind those endpoints. Yeah. So that even if someone sees them, they can't abuse them.
Okay, I get you. I think his argument was like the endpoint shouldn't be visible on the network. So I don't know. I thought there's a way that somebody can hide. I know you can disable inspect, but someone can bypass that by opening another tab. But his argument was like you should. There's a way you can hide them, but I didn't get it up to now. So okay.
Well, if the auditor requests you to hide, then I think you can hide them, but it's not compulsory for you to hide it. Just make sure the endpoints are secure.
Okay, cool.
Yeah.
Thank you.
Okay. Charles?
Yeah, thank you so much. Now, my question is, as a microservice developer, what are some of the challenges you face in your role?
Diana?
Oh, so some of the challenges I face is sometimes in everything in microservices, every service is separate, so they have to talk over the network. So the challenge is that one service can be slow, maybe the service that I'm calling, and it can affect my service or other services. So you have to handle timeouts and failures. And also debugging can be quite hard. So since microservices are distributed, bugs can be just scattered across multiple services. And then what else? Also, the security part, you have to authenticate each and every service every time you're creating a new service. So that can be quite pain. Then the other thing is probably grasping all those services, because in my case, I've done so many services and I tend to forget. So it can get quite complex, and you could have done a service like last year and it breaks or it goes down, and now you have to resolve, and you probably can't remember what it was doing. So that's the other challenge that I have. And also having many services, it is your responsibility for you to monitor them, and it also becomes a challenge because you have to constantly check whether your service is in operation. Utaangusha service and then now affect the customers. Then yeah, I think those are mainly the things that the main challenges I face working with microservices.
Okay, you are the developer, and again, you are the one who is doing debugging and all that. I thought there's supposed to be somebody who actually, after you're done, then you push to them the code, they check, then they return to you, so that you make the correction in certain areas. Then I think you must be finding it rough.
I think I also mentioned this. I said it's important to monitor your services, and once you create a service, the security doesn't end there. You have to constantly monitor and make sure it's up and working in case there is any attack or, you know, the service goes down. So you have to, it is your responsibility. You take ownership. It is your responsibility to make sure it is in operation. Yeah, so yes.
Okay, thank you.
Yeah.
Martin?
Hello, everyone. Thank you, Diana, for this presentation. As a software developer myself, I've constantly asked myself questions on how to strengthen my applications. And from what I've heard from you, you've mentioned validating inputs, you've mentioned best code practices to enhance the security of your applications. So I wanted to know, do you use any other tools, especially cybersecurity tools like pen testing or PubSuite or Nmap as you do your security checks for applications? If so, you can confirm and maybe give us your routine that you use to secure your applications. Thank you.
Oh, okay. Well, I don't do the tests. I don't do the test personally. There is a team that is assigned to do the test. So my work is to ensure the services cannot be penetrated by the security testing team. So to answer your question, I haven't used any of the security tools, but I have knowledge about them and what they do.
Oh, thank you.
Charles?
Thank you. I wanted to ask Diana, are microservices really only possible to be done in containerized environments? Or let's say, for example, a user who is using a simple hosting service that is providing cPanel as the hosting service, can you deploy microservices there with maybe the subdomains and have the authentication subdomain, maybe have the processing subdomain and something like that?
Services are not just limited to the containerized environments, though I think those environments do provide more benefits when you're working with microservices. So microservices are just more of an architectural style than a deployment rule. So it just makes sure it handles one responsibility or a single purpose. So to deploy services and subdomain, you can just use REST APIs to communicate between services. But now the limitation is that, shared hosting environments run all your services at the same server process, which can be harder to isolate those failures. And when it comes to now scaling, the containers let you scale the services independently. But now with cPanel, you'll be limited with how much you can scale one service without affecting the others.
Okay, answered.
Yeah, but if you're building just a small project and just want to try out the microservice approach, it can work.
Okay, sawa.
Gerald?
Hi, I have a question. Let's say you're building a project, and probably it starts out as a small project. So my question is, at what point do you get to decide or get to tell whether you need or you don't need microservices?
I think you don't need microservices. You can just use the monolithic architecture. So when do you decide to switch to now microservices? If your application gets big, some things now starts making the application heavier, and some things just starts to appear. That's when you know you need microservices, and now microservices will make more sense. So I think, it's basically that if the code base becomes too large to manage.
Great. One more question is, I had an argument with someone. They were trying to tell me that true microservice should be a fully standalone service, all the way from the database to the backend and to the front end. Having worked with microservices, is this a statement that is true, or it's up for debate? What are your views?
You have to work with from what to backend?
All the way from front end, back end, and the database.
Well, yeah, it's true. It must be a standalone or standalone. It should be a standalone and have its own database and front end. But then with microservices, you can be able to. With microservices, you can be able to deploy the units independently, and then you can be able to develop the microservices can be owned and developed independently by teams. And why microservices why they don't need their own backend or front end is because every microservice has its own logic and API. So it's often recommended, but it's not always enforced. So it's the best practice is to just avoid, tight coupling, and in some organizations, services can share database but only access specific table. So because the shared databases can lead to tight coupling and break the principle, you build it, you run it. So I don't know if I answered.
Yeah, I got it. Thank you.
Any last question? Okay, so I'm making sure we haven't left anyone out. Any last question? Yes, Felix.
Yeah, hi. Nilikuwa na swali. When you are testing these endpoints, do you use Postman now at work?
I use Postman. We also have CI/CD, which tests the Trivy, which scans for any vulnerabilities in the service before it is deployed. So before you even deploy your service, it goes through testing in the pipeline. So you test locally, and also it also goes through a series of tests before it gets deployed.
So it's all automated, or at which point do you you start automating the process?
Yes, it's all automated. Well, it's automated by the DevSecOps team.
Well, okay. And also about microservices, I wanted to comment that it could be all on the same website with the loosely coupled components within. Like
Yeah, it
I
can be
personally
in,
on a
well, you can
system that
have
is
them. Okay, you can have them independently, but then now use them in the same application.
no, I mean like they share the same database.
Oh,
and
yes.
the same, yeah. But individually, there are different separate modules in the same application.
Yes.
It was just a comment for the last person who asked the question.
Oh, okay.
Okay. Thank you, Felix. So let me just give it back to you, Diana. Any last comments for the night before I bring the session to a close?
Oh, okay. I'd like to say thank you so much for your time and energy. And I hope that this helped you to see security not as a scary topic, but as an essential and exciting part of tech. And feel free to connect and reach out. I do try to share some time-lapse videos just to keep viewers maybe motivated on my platforms. You can find me on Dida Codes on Instagram or TikTok, and you can also reach out via email. Yeah, thank you for this opportunity once again.
Thank you. Thank you so much. Yes.
You've already
Yes.
shared your Instagram and TikTok. Do you have an X handle?
Sorry, what?
Do you have X handle, like X Twitter?
Oh, yes, but I do not post tech
sorry.
content. Yeah.
It's okay.
Okay. Thank you so much, Diana. It's been quite a lovely session. We've really enjoyed, and I'm sure even if someone is not tech-based or code-based per se, they've been able to understand what is going on. Thank you for just making it very relatable and just simplifying it. Kila mtu ameelewa. Thank you so much. And we hope to invite you for other sessions as a mentor here. Also, I usually advise when someone comes on the call and you find the topic is quite relatable to what you do, feel free to respectfully reach out through, let's say, their different platforms and just ask questions, interact, see how you can build yourself beyond just this platform. So again, thank you so much everyone for participating, for the questions that were very relevant, and just making the session a lively one. Okay, so good night everyone and see you next Thursday. Bye. There's a hand that keeps on going up from Kasongo. Is that a question? Sawa, we've recognized your hand. Good night, everyone.